laser systems are rapidly emerging as a crucial complement and, in some cases, a direct replacement for traditional radio technology in military communications. This significant shift is driven by the inherent limitations of radio frequency, or RF, communication in the complex environments of modern warfare and space operations. RF communication, while foundational, exhibits vulnerabilities to interference, jamming, and detection by adversaries. As one expert succinctly put it, the radio era is not over, but lasers are taking over more and more of the most critical communication links. Traditional radio communication has long served as the indispensable backbone of military communication for many decades. It remains a proven and standardized method for transmitting vital voice, data, and telemetry across vast distances. Its robustness and global standardization have made it a reliable workhorse in countless operations worldwide. However, traditional radio also presents significant weaknesses in today's contested environments. The RF spectrum is becoming increasingly congested, limiting available bandwidth for critical military operations. Furthermore, radio signals are highly susceptible to electronic interference or deliberate jamming, which can severely disrupt command and control. Critically, RF transmissions are easily detectable by enemies, compromising operational security. This reliance on a limited spectrum further exacerbates these challenges. Laser communication, also known as optical communication, offers a compelling solution to many of these RF limitations. This advanced technology utilizes narrow, focused beams of infrared or visible light to transmit information. By leveraging light waves, laser systems can transmit significantly more data at much higher speeds than traditional radio. This method also offers a substantially lower chance of interception compared to the broad propagation of radio waves. Major defense and space programs are now actively investing substantial resources into the development and deployment of laser communication technology. The U.S. Space Development Agency, or SDA, is a prime example, building an extensive satellite constellation that relies heavily on laser links. This ambitious project aims to create a secure, high-speed data network spanning both space and terrestrial assets. The SDA's vision involves a resilient mesh network designed for faster, more secure data transfer across all domains. Despite this enthusiasm, government oversight bodies have expressed caution. They note that the technology has not yet been fully demonstrated operationally in space before these major investments were committed. Concerns include potential cost overruns, technical complexity, and logistical risks associated with such a rapid deployment. Nevertheless, industry partnerships are accelerating the development of Phase 2 prototype laser terminals. These terminals are crucial for enabling cross-link communication among U.S. military and allied orbiting systems. Commercial space companies are also playing a vital role, producing advanced long-haul laser communication terminals for their own satellite networks. This commercial activity illustrates the rapid progression of laser communication from theoretical concepts to practical, real-world deployment. Laser communication offers several compelling advantages for military applications. It provides exceptionally high data rates, often orders of magnitude greater than what radio waves can achieve. Its highly focused beam results in low detectability, making it significantly harder for adversaries to intercept or jam. Furthermore, laser communication reduces spectrum conflict by utilizing light, thereby avoiding the increasingly crowded radio spectrum. However, laser communication also has practical limitations. It fundamentally requires a clear line of sight and extremely precise pointing, which can be challenging to maintain between rapidly moving platforms. Terrestrial optical links are also susceptible to degradation from atmospheric conditions such as clouds, rain, and turbulence. Therefore, laser communication is currently seen as a powerful complement to existing radio systems, rather than an outright replacement for all scenarios. Significant demonstrations have already proven the viability of laser communication in real-world scenarios. NASA's Deep Space Optical Communications, or DSOC, project successfully demonstrated laser links between Earth and a spacecraft millions of miles away. This achievement highlights the technology's ability to transmit large volumes of data over truly vast distances. DSoC notably outperforms traditional RF links in terms of data volume transmitted over such immense distances. Beyond space, European and NATO partners are actively experimenting with optical communication systems for various military applications. These efforts include developing secure naval and airborne communication links. Such initiatives underscore the growing confidence in laser technology for critical defense needs. The future of military communications will undoubtedly involve a sophisticated blend of both RF and optical links. This integrated approach will leverage the strengths of each technology to create a more robust and resilient network. Potential applications are transformative, including airborne platforms linking directly to satellites at gigabit speeds. This capability would allow aircraft to exchange high-resolution sensor data securely and instantaneously. Laser communication is poised to form the backbone for integrated joint battle networks, seamlessly connecting air, land, sea, and space assets. This represents a fundamental shift from wide-area broadcast radio to precision, high-capacity laser networks. The ultimate aim is to establish a more reliable, secure, and efficient communication infrastructure for modern defense operations. Laser communication is no longer a distant, theoretical idea. It is actively being deployed, rigorously tested, and substantially funded across global defense and space sectors. Optical links offer inherently faster and more secure data paths, particularly in environments where traditional radio may be vulnerable or simply insufficient. While the complete transition will not happen overnight, the trajectory is undeniably clear. Laser communication is increasingly complementing and, in specific use cases, demonstrably surpassing the capabilities of traditional radio.